Polyprotic acid um, is an acid that has more than one ionizable hydrogen atoms per molecule, or another way of saying is they have more than one proton to donate. For example, H2SO4. H2SO4 can donate 2 protons, and this is a diprotic acid. Similarly, if you look at this phosphoric acid can donate 3 protons, so it is a triprotic acid or a polyprotic acid. Now, the removal of this proton, these 3 protons, takes place in 3 steps. So if you look at the first step, it is donating first proton and converting into H2PO4 negative. This H2PO4 negative is the conjugate base of H3PO4, and this is the acid dissociation constant value. Now, here you start with this one, you again write down the acid-base reaction, and in this step you remove the second proton, and in this case you remove the third proton. And look at these values. Ka1, that means the acid dissociation constant 1, that value is much higher than the other two. What does that mean? That means it is always easy, it's easy to remove the first proton. And why is that? Because you are removing, in this step, first step, you are removing first proton from a neutral substance. H3PO4 is neutral. You're getting rid of 1 proton. Remember I said put plus minus, get rid of 1 hydrogen with 1 positive charge. What you are left with? H2PO4 negative. Now, what you have to do in second step and the third step, you have to remove the proton from a negatively charged species. And it is hard, because it is hard to remove a proton, hydrogen with a plus charge, from a negative ion. And that's why these values are very small. The next is the acidic or basic nature of salt solutions. When you are reacting acid with base, it forms salt and water. Now this salt, whether it is going to be acidic, basic or neutral, depends on what kind of acid and base you're taking. Let's look at this reaction. For example, HCl plus NaOH gives NaCl plus H2O. So H plus from the acid, OH from the base are combining to form water. And then here is Na and Cl, and that is forming salt. It's a double displacement reaction. HCl is a strong acid. Base sodium hydroxide is a strong base. If the salt that is formed from a strong acid and the strong base is neutral. Why is that? Because HCl is a strong acid, its conjugate base is Cl negative, and it will be very weak. Remember, strong acids produce weak conjugate bases. NaOH, the corresponding cation will be Na plus. And since it's a strong base, its conjugate acid is going to be very weak. So weak and weak cannot make something strong. So the important thing is, if you're using a strong acid and a strong base, the salt will be neutral. Let me go to the next slide where I have questions. So is sodium chloride acidic, basic, or neutral? The best way to do these questions is You write down, let me use another color pen here. NaCl, break it down into two, Na plus, Cl negative. With the positive one, write down OH. With the negative one, write down H. Remember, we are getting rid of water. So that means NaCl is made up of sodium hydroxide and hydrochloric acid. Sodium hydroxide is a strong base, and hydrochloric acid is a strong acid. When strong acids react with strong bases, they produce neutral salt. Because why? Because their conjugate bases or conjugate acids in the solution, they are very weak. Do the same thing here. Sodium nitrate, write it down like this. What is sodium nitrate made up of? Na plus, NO3 negative. Now, then write down OH negative next to the positive charge and H plus here. What is this made up of? Sodium hydroxide base, which is a strong base, nitric acid, which is a strong acid. So strong acid-base reaction gives you neutral solution. Let's look at the next one. Ammonium nitrate, break it down into ions. What it is made up of? Ammonium ions and nitrate ions. Remember, we write down OH next to the positively charged, H plus next to the negatively charged. So it is made up of ammonium hydroxide and nitric acid. Nitric acid is a strong acid, ammonium hydroxide is a weak base. Strong acids in the solution produces weak conjugate base. Weak bases will produce strong conjugate acids. So here's the thing, if your salt is made up of strong acids and weak base, your solution will be acidic. If you're just trying to remember it, you can say whatever the strong is, the corresponding solution is going to be like that. I have strong acids, so the solution is going to be acidic. But the point to understand is, since it is made up of weak base, then the weak base in the water, what will it do? It will produce strong conjugate acid, and that strong conjugate acid will basically make the solution acidic. So this is my NH4 plus in the water, and that, put it in the water, write down the reaction. What is produced? Strong conjugate acid, and that's why the solution is acidic. Let's look at, I should have taken one more example of, let me go to the other slide and take this one. For example, sodium acetate. Sodium acetate. Easy way to figure it out is, it is made up of sodium ions and acetate ions. Put OH here, put H plus here. It is made up of sodium hydroxide and acetic acid, strong base, weak acid. Corresponding solution is going to be basic. Whatever the strong is, you write down here. But ultimately, you need to keep in the mind that why the solution is basic, because this weak acid in the water produces this weak, let me write down separately. So why it is basic? Because when you have this acetate ion, from here, it is from a weak acid, right? Acetic acid. So this in the water produces OH negative, and that's why the solution is basic. The last example here is ammonium acetate, acidic, basic, or neutral. Now for this one, what you have to do is, first again, let's say break it down again. So ammonium acetate is made up of ammonium ions and acetate ions. And if you look at it carefully, ammonium ions, what will be, so it is made up of from ammonium hydroxide and acetic acid. Just to show you here, both ammonium hydroxide is a weak base, acetic acid is a weak acid. That means this salt is made up of weak acid and weak base. That means when we are going to put them in water, both of them will produce corresponding strong conjugate acids or bases. Then in this case, how do you decide whether the solution, the salt, is acidic, basic, or neutral? So let me pick a different slide. So here I have how I'm gonna just show you that how the salt was formed. Acetic acid with ammonium hydroxide gives this, you can write down like this also, one of the same thing, CH3 and plus water. This is a weak acid, this is a weak base, both of them producing the strong conjugate acid bases. In this case, what do you do? Weak acids, this has some Ka value, and weak base has some Kb value. If Ka value is greater than Kb, then salt is acidic. If Ka value is less than Kb, which means Kb is greater, then salt is basic.